Hello everyone, it's the third videos. In these videos we will discuss about section menses for Berlin to type sigma, z, c, etc. So I do some research to cut the catalog of this section. So via AutoCAD website we have this section to add in our program to have this section. So from tools, preferences, then not this, so from tools, job preference, and then database, steel and timber. So we can add, for example, so the browser. So we have ColdPro, open, okay. Then the second one, StadePro and OS Pro. So this open, so open, okay. So we can find what we added here. So ColdPro, so we have sigma, so we have this section, and for it we have this section. So for our cases, S200 with thickness 1 millimeter 0.6, so it is not enough. We need at least 2 millimeters or 3 millimeters. So we can change, for example, here we have C section, we have Z section, so we have this, we can add it for C. So for C we have 3 millimeter, we can add it. In other catalog we have C, so we can find many type, Z and C. We have L, so we will try it and see the difference. So here, for example, C, so this is a profile. Normally we need C because it is the thickness is very small, and it is not the same rigidity to the two profile. But here the material, the yield stressness for section menses is about 355. It is not 235. So we should change it. It is not for all. It's just for the big section. So sigma, for example, over around 200 millimeters. The material is about 355. In some companies, all the dimension is about 355. For C and sigma, it depends. So you have to you have to record to the catalog of the company to assure we use the good materials, and it is very important. There is a big difference because the elasticity is a elasticity region and plasticity region is not the same. Deformation is not the same. The stress is not the same. So here Z, we can see I will add sigma. I sigma, for example. I don't add it sigma, so I try to find sigma. I will try this. So you can see the difference. So I will suppose the material is 355. I will change all the section. The offset. The same way I can change from here. Where is EBE 100? Ah, it's 160. Wow. It's complicated too. So here I can change it, sigma, and the material, it's very important. Second time I will copy it, but I think we are good. So I will copy it, move, so it is the position we can find in all structure, but we can put the purlin inside the frame, and in this method we will reinforce the frame, and the length of the buckling, lateral buckling, we will base from 13 meters to 1 meter 30 centimeter, 1.3 meters. But we will pay attention about the connection between to transfer the effort from the sigma to the frame. So when we design the connection between purlin and frame, we will choose thickness of a plate important because of the shear forces, the effort from the purlin will transfer to the frame by this blade, and this blade dimension by shear forces. The bolt in the same way. Here the bolt will dimension it from shear forces, not for traction. So we will find out this information in the lateral buckling, and we'll see a lot of difference here, and the section of the profile will raise cause to the lateral buckling, and it will cost pricely. So that for these videos. We'll see in the next lesson. We have many subjects to discuss. So see you in the next video.